I'm guessing we'll do announcements at like 12:05.
Yep.
So do we need to sign in on my bar to be here?
Yeah.
Yeah.
We're
Okay,
checking
cool.
attendance on my bar.
And the sign-in link here goes to my bar, by the way, just in case.
All right, it is 12:05, so I think we should get started now. So welcome everyone. Welcome to the Intro to Linux meeting. We're gonna have a Linux meeting and workshop later this Friday. It's gonna be super great. We got Gabe and Justin to present about Linux. Is gonna be pretty awesome. So let's start out with announcements. And the only announcement we have is become a paid member of Swift. We got really cool stuff for you, including t-shirts, stickers, webcam covers. If you want to be like Alex and have a pop socket, we can have those as well. We're going to be doing raffles throughout the year, throughout the semester, where you can have a chance to win a Raspberry Pi. And for any of the competitions and events that we have, if you become a paid member, then you can qualify for those. And there's a lot more coming up. Other things such as having one-on-one mentorship with industry professionals is another benefit that you get if you are a paid member. Same thing with the certification reimbursement and our first ever red versus blue, which we want to push up for all of you to get more hands-on experience through a live adversarial and defensive simulation. The link below is how you can sign up to become a paid member, and it's $20 a semester or $35 for the entire year. All right, with that being said, yep, please become a paid member. It'll be pretty awesome. And I think we should get started. So I'll hand it off to Gabe and Justin to talk about Linux.
Thank you very much, Taylor. So welcome everyone to our introduction to Linux. I'm Gabriel and I'm joined today with my wonderful eBoard co-host, Justin. And let's just get right on with it. So here we have a basic overview of what we're covering today. I know it's only 4 segments, but trust me, there is a lot to cover. So let's get right on with it then. We're going to start off with an overview with what Linux is. And even if this is your first time learning how to spell Linux, or you're just getting your feet wet for the first time, it's important to know what exactly we're working with. And to give a very succinct answer, Linux is simply a kind of kernel, but we'll get more into what that means specifically in a little bit. Let's start actually with what Linux is mostly used for. By far, the #1 thing that Linux is known for is servers. Approximately 96.3% of the top 100 million, I believe, servers in the world are using a Linux distribution. And I believe as of 2021, all like 500 of the world's supercomputers run a version of Linux as well. And that's not even to include the billions of mobile devices. Ever heard of Android? That is a version of Linux as well. And obviously, all of these different devices aren't using the same exact quote unquote Linux distribution. And what that really means is that Linux, when we say like, oh, I run Linux, or so-and-so is running Linux, they're describing the family of flavors of Linux. And flavor is just a term to describe like a particular operating system that incorporates the Linux kernel. And again, I'll get more into what that means on the next slide. But the important thing to take away is that there's a lot of different kinds of operating systems that all use the Linux kernel. And the reason why so many different operating systems and so many devices all use Linux is because it's very lightweight, it has high customization, and it's open source. The benefit of being lightweight is pretty intuitive. It has less stuff on the hardware, and that just means that you're not being bloated by as much other stuff. High customization is very, very good for servers, because if you want something to be done a certain way, you can do it. If you want something to act a certain way simply because you like it, Linux is perfect for you. And lastly, being open source, that means that there's more eyes on the code for the Linux kernel. And the more eyes, the faster security issues and bugs can be fixed and patched. So all of these factors are pretty much why Linux is number one when it comes to servers. When it comes to other things like, well, how many regular users like you and I use Linux, we'll touch on that in a bit. But here is the technical explanation about what Linux is. It's a little bit of geeky information. It's not the most important to know when you're using Linux, but it's just nice to know. So when people are describing different aspects of a Linux system, you have a better idea of what we're dealing with. And as I said, Linux is simply a kernel. It's part of an operating system. In and of itself, it is not an operating system. And that's because a kernel, you could think of it as the part of the operating system that just handles resources. If the operating system needs more memory or resources from a particular part of the hardware, the kernel is going to talk to that hardware and give it the resources it needs. And when those resources free up, it will put it back into the available pool. That's a very high level overview of what a kernel is. And if you're a little bit confused as to, well, how does that separate, how is a kernel different than an operating system? Just think about it as the operating system is going to have a lot of other stuff included, like the bootloader for when things are starting up, an init system, graphical user interface, et cetera, et cetera. All these different things are also part of the operating system, but they're also entirely separate from the kernel and from each other. As I mentioned, the kernel is just one part of the operating system. And that means that you can build many different operating systems using the Linux kernel, and it will still be Linux. And because of this, again, that's part of the reason why there's so many different versions of Linux, because there's just so many different ways you can put different things together. Again, it's open source, so anybody could make their own operating system if you wanted to. Just put together all the different parts you'd like, and you might be running your very own customized Linux version. Now, if you are coming to Linux for the very first time, then I've created this graphic for you. So whatever you're more familiar with, you'll have a better sense of what you'll be getting with Linux. We'll start off with Mac OS or OS X. It's a very, very UI-focused operating system. It's not focused on user control. And you can kind of see that in the core features of how Mac OS is designed. It's designed to be very, very intuitive. Even if you're not very comfortable with computers, the way that it naturally functions and works just kind of makes sense with what you expect from a computer. This makes it perfect for casual use or as a workstation in a business. But unfortunately, because all these things are so high level and meant to be easy, it actually has very limited out of the box like functionality, at least compared to Linux. Mac OS is going to have a lot of like safety cushioning and pillows, so you can't really get too confused or break the system in any way. And we're going to move on to Windows, which is pretty much the same story, but it's a little bit more of a middle ground between Mac OS and Linux. It's also very focused on UI and focused on being intuitive, but it gives the user a little bit more flexibility when it comes to configuration and overall use. And obviously, the last thing we have to talk about is Linux. And Linux, like I mentioned, has so many different flavors or kinds of operating systems that use the Linux kernel. So it's kind of hard to say that it's designed to be UI focused, since it's entirely up to how the developer of that particular flavor wanted it to be. For example, Ubuntu, which is a very popular Linux distribution, is pretty focused on UI. It's meant to kind of be a competitor with Windows and Mac OS. However, other distributions of Linux like Arch, for example, don't even come with a GUI most of the time. You have to install that manually. But because of this, because it's so flexible and has so much configuration, it makes it perfect for servers. Because servers are oftentimes used for pretty much anything, and having all this free reign and user functionality and control, it makes it perfect for doing whatever you need it to do. So hopefully that gives you guys a good idea of what to expect. We're going to move on to the Linux file system. And a lot of these things, even if you think you're an aficionado in finding all your homework folders and downloads and whatnot on macOS or Windows, it's important to know some of these core, at least vocabulary differences between Linux and whatever you may be more familiar with. The first thing is a very simple switch, directory. It literally just means folder. It's the exact same thing, but in Linux, most people tend to call folders directories. Like I said, they can be switched between, it doesn't really matter, but it's just important to know because of the very next thing we're talking about, which is the root directory. The root directory is going to be the starting point of your file system. Everything that's a part of your file system, all of it is inside of the root directory. It's the biggest possible directory you could have. And it's denoted by the single slash or a leading slash. And you'll see where we might find that when I talk about file paths. So just hold that thought for a moment. The next thing we're going to talk about is the root account. Now, it's called the root account, but it doesn't really have to do with the file system itself. The root account is basically the God user or the administrator account that comes with all Linux distributions. Some important things about it is it has the user ID of 0, which basically means it is always the first user that is possible on a Linux system. And you can sign into the root account, but you also have other ways of getting that administrator or God level control with the computer, and we'll cover that in a little bit. But the last thing we're going to talk about before then is file paths. File paths are a very, very important part of using Linux. If you are more familiar with Windows and Mac OS, you probably haven't used file paths, but you probably have a slight idea of what they might look like. And I've prepared this little diagram for you to kind of warm you up to the idea of how to use file paths. So as we can see here, this is a very, very simplified diagram of a file system. But at the top here, we have the root directory. Again, it's denoted by the single slash. And we have two subdirectories here. For example, home and temp. One important thing to note about file paths is their relation to the user and the relation to the root directory. And when you are using the Linux system of your choice, you're going to have, a user session, right? You're going to be somewhere in your system. And usually you can only be in one position at a time. If you have like different terminal windows open, well, then you can be in multiple places, but each terminal window can only be in one place at a time. You might be in like the root directory, or you might be in the temp directory. You could be in any directory you want. But the important thing is you can only be in one place at once. And this is important because of file paths. There are two kinds of file paths, absolute and relative. The first is the absolute file path. And you'll see here with these two examples that they always start with the root directory, or that leading slash. The reason why they're called absolute file paths is because of this fact that they always start at the root directory. It doesn't matter where you are in the system, you're always going to be specifying to the Linux kernel that whatever you're talking about, you're going to be giving it absolute address, or the absolute file path of that file, right? It always is going to know where to start because it knows it's starting at the root directory, and then it goes to each subdirectory until it reaches the file. However, for relative paths, it's using the user's current location to define where it's going. So for example, if our user was in the nginx folder right here, so in the root directory, then you go to /etc, then the nginx directory here. Then if we were to use a command and we wanted to refer to this file nginx.conf, we could just have nginx.conf, and the system will know, hey, I'm in this directory right here. I'm looking for a file with this name in this directory. As you can kind of tell, it makes things a little bit faster. You don't have to write as much or type in as much, but you do have to know where you are and where what you want is. So that's kind of like the trade-off between absolute paths and relative paths. Another way you could write a relative path is with this syntax. So in this case, we have a leading period in front of the slash. So this is actually not a leading /. It's a leading period or dot. The single dot is a symbol referring to the user's present working directory, which just means wherever they currently are in the file system. So if we go back to this diagram, then if we were in /tmp or /temp, then the dot symbol would be talking about this. If I was in the user1 directory and I use / whatever, it would know that that / is referring to user1. And if you guys have any questions or anything might be confusing, or you just like some more clarification, feel free to drop the question in the chat, and we'll be happy to answer that for you. But yeah, so that's pretty much the gist of file paths. You're going to be using them a lot in Linux because whenever you want to edit a file from the command line, you're going to have to tell your system which file you want to edit, and a whole bunch of stuff like that. And now Justin will kick you guys off with some terminal terms.
Thank you, Gabe. So I'm going to be going over pretty much what the Linux terminal is, how it works, as well as some basic syntax for it too. Next slide. Okay, so pretty much there are three main things that you need to know. So a terminal emulator, the command line interface, and the shell. The terminal emulator is just the program that is going to be ran to host the command line interface. So on Ubuntu, it's just called terminal, and on other distributions, it would be called something else. And you can also get different terminal emulators. The command line interface simply is just where you're going to type in the commands that you want to run. And the shell is something that runs more in the background and acts as the syntax and rule set for what you're going to type in. And now I'm going to go over some basic syntax for the shell. So it's going to follow an almost universal structure of the command you want to run, the options / flags that you want to use with the command, as well as the argument. The argument, when I mean that, I'm meaning something like a file or a directory. So For here, I'm just doing ls-a in my home directory. So that's also going back to relative paths. So I don't specify any argument. So it's just doing it at the dot directory, which is my current directory. And so ls-a is the shortened version of ls-all. So a lot of commands that are common will use just a dash. So -a to list all files, even hidden files. But some do need the dash that aren't as common. And also another thing to note about just using a single dash, you can chain together. So you can do ls-a and or ls-la to do all files and the long format, which lists the permission of each file. Next slide. So going on to the next part of the shell. So you can actually view documentation for pretty much every command just by using the man command. So you just run man and then the command that you want to do. So like man for ls will show you every option for ls and just like what it does. So there's also -h or --help, which acts as a shortened or condensed version of the man page. So, and oftentimes this will also have different examples that you can do for chaining the commands together to get different results. So for a lot of like non-native Linux tools, you'll do --help and it'll give like what options you can use together to get different results. And also some options or flags require their own arguments. So for example, here we have doing an nmap scan, which pretty much just will scan a computer for all open ports. So, and we have the -on flag, and it's going into the scans directory in a file called nmap. So this, what on is doing is it's outputting it in the normal format. So it's just taking what it would display on the screen and putting it into a file. So yeah, and there will be other arguments that you have to use with other options as well. Next slide. Okay, so next we move on to the different shells that there are. So at the very basic, there is sh. This was the first shell ever developed back in, I think it was the 70s. It's it just works pretty much. It doesn't have any higher level functionality really. You can just do very basic stuff with it. But after that, around in the 80s, bash was made, which acts as you can do more with bash. So you have more customization. You can create your own aliases, which is pretty much just a shortened version of a command. So say you want to do a ls-la scan, you can just have it be la and have that run ls-la. And there's also something fairly new called the Z shell, which is just something that runs off of bash that provides a lot more customization. Okay, next, yep. So like I mentioned before, bash, it is definitely the most common shell on any Linux distribution. It is what comes default with most, if not all, Linux distributions. So yeah, whenever you open a terminal, bash is the shell that is running. Next slide. So yeah, some basic commands for navigation. So the three that are really important is cd, ls, and pwd. CD is simply just changing directory. So, but this also works with absolute and relative file paths. So if you're in your home directory and you want to go to desktop, you can just do cd desktop, or you could do cd/home/justin/desktop. They both work. Same with ls. You can run ls on say like /etc to get everything in etc, or you can just do ls for the current directory. And pwd is print working directory, which just will display the current directory that you're in on the terminal screen. So yeah, just some basic file and directory manipulation commands. So there is touch and mkdir to create a file and a directory in specific, or and there's also rm and rmdir, which rm just removes a file, but you could also do different flags with rm to delete a folder, but there's also rmdir to just remove a folder outright. There is also cp or mv. So cp is just a copy and mv is just to move. So the syntax of cp and mv is cp or mv, the file that you want to move or copy, and the directory to which you want to move it. So if you just do dot to move to your current directory, you can do that, or you can do /home/justin/documents or something like that. And there's also a command called cat, which pretty much will just print out the contents of a file onto the terminal screen. And you can also do different, there's also a tool called grep, which will do pretty much pattern finding. Think of Control F just in your basic web browser. And you can do that with options to find certain contents of a file that if you're just searching for something. And then there's also Nano and Vim. These are both terminal-based text editors. And Nano is it's a lot more basic than Vim, but you're also able to do a lot more with Vim. I personally use Vim and it saves me a lot of time. So if you're trying to learn how to use one of these two, I'd say start off with Nano, and then if you want to learn Vim, because there is so much you can do with it. Next slide. So the final section of the basic commands, pipes and packages. So you can use the single pipe option to pretty much use one file's output as another's input. I mentioned grep for pattern finding. So here we have, I'm using cat to print out the contents of the shd config file, and then using the pipe to use that output to grep's input. And then I'm using the -i flag for case insensitive and searching for root because I'm looking for permit root login. But you can also see that I get something chroot directory, and I don't want to see that. So it's always better to be more specific if you're going to use grep, because you might run into things like this where you get something that you don't want. And also, on pretty much all Linux distributions, you can use packages and package managers to install software. So on Ubuntu, it's something like apt or dpackage. On Arch, it would be pacman, but you can pretty much just run apt install and then the package name that you want to install, and it'll just install it with all its dependencies for you. And also, like Gabe was talking about with the super user or root. So you can do sudo to run commands with root permission. So what this does is you put it before any command and it just will run that command as root. So a lot of times when you're installing packages, you're going to have to use sudo because you need root permissions to install packages. Okay, and now I'm going to throw it back to Gabe for some tips and tricks.
Thank you very much, Justin. Great stuff. And yeah, I'm going to be covering some tips and tricks so that you can be a little bit faster, or have some additional functionality that you might not have known about if you're new to coming to Linux. So yeah, let's just get right started with it. First off, we're going to do some speedy time-saving shortcuts. The very first thing that we're going to talk about is Control L. So Control L, very simple. All it does is it clears your terminal. It basically just does a bunch of new lines so that all of the old output that was in your terminal just gets pushed away and hidden. And this is just a way to clear your terminal in the sense that you have a fresh working environment. You don't have to mentally think about all the things that are on your screen. It's just a very nice, clean slate without having to open up a new session or anything like that. Yeah, I mean, in most distributions, if you scroll up, if you have a GUI or something, you'll be able to see whatever you had in case you might want that. But yeah, it's going to just wipe your screen basically. The next thing is tab completion. This is something that if you have done anything with an IDE, like computer science or programming, you might be familiar with it. Even if you play Minecraft, for example, that has tab auto completion as well. But basically, as you're typing something, the Linux system knows about everything that you could possibly type, right? Because it's trying to check if what you're typing is valid. once it reaches a point where you've typed in enough that there's nothing else it could possibly be except for one thing, if you press the tab key, it will just finish typing in the rest for you because it knows there's nothing else. The rest of the characters are kind of meaningless. It's just, for formality's sake. So you just press tab and it fills it in for you. Again, I want to reiterate, this only happens if you are at the point of where there's nothing else it could be. If there is, for example, multiple things, the terminal usually will just show you all the different possibilities you have left. So say you had a file called file1 and file2. If you were to just type in file and then press tab, it'll just show file1 and file2 because those are the only things you could have that match up to that point. And if there is nothing left, like what you typed in doesn't exist, it's not a possibility, when you press tab, it'll just not autocomplete. So if you're pressing tab and you're kind of confused, like how come nothing's happening, it's probably because you made a typo somewhere and it's actually not matching anything so far. But it's a very good time-saving trick if you're typing in like a really long file path and like, for example, there's only one directory that starts with a W and that's the one you want to start, then you can just type in W and tab and then it'll finish it. Even if it's like 10,000 characters long, if that's the only one with a W, you type in a W and press tab, you're good to go. The next kind of speedy shortcut is CD tac. I would like to point out that this is like the tac symbol, the dash. It's not like the underline. It's not like a hyphen that's in Unicode or anything like that. This is just like tac. So when you do this, it's going to send you back to the directory you were most previously in. Most Linux distributions track where you last were for this feature. So if you're hopping between two directories constantly, then you can use CD tac and it'll just keep hopping back and forth between those two. One thing to note is it's not going into your directory history. So it's not like keeping track of multiple, it's only keeping track of your most previous one. So if you do, CD tac and you go back to the previous directory and then you say use CD to go to a subdirectory somewhere, when you use CD tac again, it's going to take you to the directory you're most previously in, which is just, up one directory, instead of going back to wherever else you were working in. So it's just one thing you have to keep in mind when you're using that shortcut, but it's very useful if you're, swapping between two different directories. And the next one that we're going to talk about is CD tilde. If you've never used the tilde character before, it's to the left of the 1 key in the top of the keyboard. And what that's going to do is it takes you to your user's home directory. So if you're logged in as, let's say, Justin, or you're logged in as Gabriel, then when you type in CD tilde, it will take you to /home/Justin or /home/Gabriel, respectively. One thing to note, if you're logged in as the root user and you type in CD tilde, the root user's home directory is not stormed in /home, which is the directory that stores all of the other users' home folders or home directory. The /root directory is the root user's home directory. It's got its own special location in the file system. So yeah, if you were to use CD tilde as the root user itself, it would take you to /root. And moving on, we have some tips and tricks for command reuse and command history. So when you're typing away at the command line, obviously you're going to be using commands over and over again, especially if you're troubleshooting, because you'll be like, how come this command didn't work? You realize, oh, I need to make this edit to this file. You'll do it, but then you don't want to type the whole command again that failed the first time. Well, one thing you might want to do is use exclamation point. The double exclamation point, very important, it's 2 of them in a row, is a symbol for the previous command. So if you, run ls, right, and then the next command you run is exclamation point, it's going to run ls again. And, it'll include all of the options, all the flags, everything you ran. But a really cool thing about this is that since it's a symbol, if you want to add something either at the beginning or at the end of your command, you could type it in. So say, for example, you were trying to run a command that required, super user privileges or root privileges, but you forgot to type in sudo at the beginning, right? So you had the right command, you just forgot sudo in the beginning. What you can do is just type in sudo ! And it will translate that into sudo and then whatever the command you were trying to run. So that's like a neat little trick you can do. I find myself using that all the time whenever I forget. And another thing you could do though is the up and down arrow keys, which will literally just be browsing your command's history. So if you remember like, oh, I remember I ran that command 3 commands ago, then you just press up 3 times and it'll be prepared for you. And you can just press enter and run that command again or whatever. And that's very, very useful. Some people don't learn about this until they've been using Linux for a little while. So it's really important that you know this. I don't want you guys to be typing in the same commands verbatim every single time. Use the up and down arrow keys, very useful. The next one is kind of similar to up and down arrow keys, but it's going to also incorporate pattern matching. So if you remember that you ran a certain command some time ago, but you can't remember, or it was been a really long time, but you just remember like a part of it, then what you can do is type in the part that you remember and then press Control-R. And what your Linux terminal will do is it will search your command history for commands that had that inside of it. And if the first one that appears isn't the one that you want, then just press Control-R again, and it'll keep cycling through your command history until you either find the command you want or you realize it's no longer being stored in your command history. And this is called reverse searching your command history. It's very useful if there is just like some command that you don't want to look up again. You remember you ran it, but it's been a while. You can just use Control-R. The last thing that we have here is alt period or alt dot, whatever you want to call it. What that does is it's going to reuse a recent argument. So say you were using some file and you're interacting with it with one command and you want to interact with it with another command, then if you use alt dot, it will bring that file name or that whatever argument you use, whether that be a file name or something else, and it'll appear there. And it goes back multiple commands and it keeps track of every argument you use, not just the last one of the last command. So you have a small list of arguments you can run through if you remember that it's there. So you don't have to type something super long, especially if it's like a URL or something like that. Alt period can be very, very useful. And now the last group of useful tidbits that we're going to cover today are some like utilities and functionalities with the command line to help you out. First utility we're going to cover is less. It's a utility, command line utility, that allows you to view output or text by page. And what that means is when you use cat, for example, which is a command that Justin covered earlier, it's going to output all of that into your actual terminal itself, because cat is not a like interactive utility. Less is. It's more similar to Nano or Vim, just without the editing functionality. And it allows you to basically just view and search files. There's some other things you can do with less as well, but it's mostly just used for text viewing. And when you exit less, it's not going to be, covering your entire screen. It's just going to go back to wherever you were. So it's really useful for viewing bigger files, and you don't want to like bloat your command line with a bunch of output from other things. So that's what that's used for. Yes is another utility. It basically just repeats input to answer prompts over and over again. You could use it to make funny text as well, but it's a very, very simple and linear command. But if you're like downloading a bunch of stuff, then you might want to use yes in some cases. Personally, I've never had a case where I really needed to use it, but it's just something nice to know in case you ever might. The next two things is going to take a little while to explain thoroughly, especially if you have no experience in programming. These double and symbols are used to combine commands or to make them run one after each other. So what it does, or the specific way that it works, is it'll run the first command, and if it sees this double and sign, it's going to check, okay, did the last command run successfully? If it did, run the next command. And you can use this to keep chaining commands with the prediction that they're going to succeed. And if the previous command failed for whatever reason, it's going to stop. It won't run the next commands. The double pipe symbol.
Is there, wait, real quick,
Mhm.
is there a way to reverse that process to, run the negation of that in Linux, where you have, where like if the command fails, then it'll run something?
Yeah, that's actually what I was about to talk about, the double pipe symbol.
Oh, okay.
It does the exact same thing that you were just trying to figure out. So if the previous command failed for whatever reason, if it sees the double pipe, it's going to run the next command only on that condition. I use this all the time when I'm running a command. And for example, if I'm like in a web shell because I'm trying to penetration test something and I'm not getting any output on the website, for example, then what I might do is I might have the double pipe, and then another very useful command is called echo. What echo does is it basically just prints out whatever you type it to, because it's literally echoing what you're saying. But yeah, so I'll just have the double pipe, and then I'll say like echo, then some debug message that I'll leave myself. And then I might see that. And then I know, oh, the reason why I wasn't seeing the command output from my previous command is because it's failing for some reason. And there's a bunch of different use cases for both of them. But the important thing to know is that the double and sign is for when you want things to run in succession because they succeeded. And the double pipe symbol is used if you want things to run in succession if they fail. There is also a way to run commands in succession without caring about the previous status of the command, or the previous command status, like if it failed or succeeded, and that's just a semicolon. It's basically just saying like run this command, don't care about that one, then run the next command, then don't care about that one, then run whatever next command, and you just separate each one by a semicolon. If you've used Java before or C, then it's very much the same as just having different lines of code. You don't have to have the semicolon if you're running individual commands, but if you want to run multiple of them in succession in one line, then yeah, you would need the semicolon there. And another thing that we're going to talk about is Control C. You might be thinking, hey, isn't that the shortcut for copying? Not in the Linux terminal. Control C in the Linux terminal is for killing the command that's currently being run. Let's say you were, I don't know, downloading a really big file, and then you realize, oh, hey, I don't need that anymore. But since it's still downloading, you can't interact with your terminal. So what you can do is just press Control C, and it's going to cancel it. It's going to kill it. Or let's just say that your command got hung up for whatever reason, like it's a command that's trying to connect to a server and it's just stalling. You just press Control C to cancel it, and then you can move on and do whatever else you need to in the terminal. You might be thinking, well, if Control C doesn't copy, then how do you copy? Well, then you just use Control Shift C. So instead of it being only 2 keys, it becomes 3. Similarly, in order to paste into the command line, you use Control Shift V instead. But yeah, that's how you can copy and paste in the command line. Different terminals might have different ways of copying and pasting as well. For example, if you have a graphical user interface, oftentimes you can click and drag to highlight the text you want, and then right click, click copy, and then wherever you want to paste it, you put your cursor there and you right click, click paste. But if you are working on a purely command line interface, there's no GUI, there's no mouse or anything like that, then Control Shift C and Control Shift V might be a little bit more up your alley. But yeah, other than that, that's all we have for this Linux crash course. We're going to have a lot more content of how to actually apply some of these concepts and commands during our Friday workshop. So definitely come check that out if you have, if you want to improve your Linux skills as well. But yeah, now we're just opening it up to Q&A if you guys have any questions.
Hey, I have a question.
Yeah, go ahead.
All right, so say I want to like mess around with Linux in my free time. Is there some sort of concept or something that I could really learn while messing around with Linux?
Yeah, one of the core principles of Linux, like I mentioned, is that it's oftentimes used for servers. So I would highly recommend just trying to set up different kinds of servers with Linux. A really easy one would be like a Minecraft server because it's really simple, but it'll kind of get you in the swing of, just, making files, downloading files, stuff like that. If you want to
Okay.
move on to more advanced things, we'll cover those in our workshop as well. And we'll also have some other, side projects we'll mention there if you want to get some more like personal projects as well.
All right, thank you. I'll start with the Minecraft server.
Yeah, that's great. Let's see. Any other questions? Do we have a cheat sheet for Linux commands? We do. We'll publish it inside of the workshop channel later on today. It'll cover all the things that we talked about in this presentation and a couple more as well. But yeah, Justin also linked another one. And yeah. Which Linux distro do I run on my home computer? Well, I would highly recommend if you're new to Linux to run Ubuntu if it's your first time using a Linux system. Like I mentioned earlier, it's meant to be a competitor with Windows and Mac OS. So it's got a really nice GUI and comes with some like Office utilities from open source sources like Libre and stuff like that, OpenOffice. So I would recommend that for a home computer. Can I practice on the terminal for Mac and translate it on Linux? So fun fact, Mac OS is actually based on Unix, which you can consider like the grandfather of Linux. They're not the same thing. Linux and Unix have kind of diverged a little bit, but a lot of the like command syntax and general use of the Mac OS terminal will translate to Linux. You might need to just like translate certain command names or package managers, etc. But the fundamentals are the exact same because of that relationship. Hopefully that answers your question, Edward. And yeah, and another thing, if you want to learn is over the wire, which Robinson and Alex have been linking in the chat. These are all really great resources to kind of warm up your Linux skills. And they have a little bit different target audiences, like Over the Wire is aimed more towards learning Linux for like penetration testing and red teaming. Linux Journey is more for like casual use and like system administration. Both of them I highly recommend if you're trying to become a little bit more of a Linux aficionado. They can go pretty deep as well. I know Linux Journey starts off simple, but it goes really deep into some low-level stuff. Linux Journey is just a website that has like some tutorials and walkthroughs with how to like use a command line with Linux and stuff like that. Thank you, everyone. Thanks for coming. Hopefully you learned something. Is there a gaming Linux distro? Now, that is one thing I didn't mention, but Linux, because it is actually used primarily in servers and not like home use or casual use, it has some limitations when it comes to compatibility, especially with like video games and stuff. Mac OS and Windows both take up a lot more of the share of, you know, the market. So a lot of video games might not have a Linux port, unfortunately. Among OS, is that a real thing, Nathan?
Yeah.
There's no way. I'm downloading it.
It's a real thing. Oh god,
There's no.
it's actually a real thing.
I'm gonna stop the
It
recording
is.
here actually.
All right, sounds
Yeah, I
good.
think
Take it
I'm
away.
basically done, but thank you everyone. Stop
Yeah,
the
if you guys need
recording,
to head
but-
to like your next class, if you guys are on campus or something, feel free. We don't want to
Sure.
take up too much of your time and like cut you guys short or anything like that.